Thank you for coming. My name is Ken Warneberg. I've got a Twitter handle of VMKen. I am a senior technical marketing architect at VMware. I cover business continuity and disaster recovery. And I'm joined today by Lee Dilworth.
Hi, Lee Dilworth, principal engineer for Europe, covering availability solutions. My Twitter handle was on the front slide, but it's been deleted, so I'm at Lee Dilworth. If you want to follow and ask me questions and things, please do. Work-related tweets only, thanks. You get some weird ones sometimes, so if you want to contact me afterwards about anything you see in the session, more than welcome.
So today we'll be talking about Site Recovery Manager 5.5 and vSphere Replication 5.5. One thing to get out of the way right off the bat, Lee and I are both from abroad. I'm Canadian, so if I say something like SRMA, I'm not actually saying SRMA. Yeah.
And I'm from the north of England, which means I have a tendency sometimes to sound a little bit Australian, apparently, to an American audience, and maybe talk quick. And unfortunately for me, Bill Fathers, who presented this morning about VCHS, has the stereotype nice English accent. So you're probably looking at me going, you're not from England because you sound nothing like that guy. So just apologies for that. Sometimes people do put in the feedback, speaker had accent. There's not too much I can do about that unless there's cosmetic surgery available to change the way I sound. So I'll do my best to keep the regionalizations down during the session today.
If we were doing this in Louisiana, we'd really be in trouble. It's not a knock, it's just a comment. So we use a lot of terminology, of course, like everyone else. We use a lot of acronyms. So some of the things we'll be saying today: SRM, Site Recovery Manager; ABR, Array-Based Recovery, which differentiates from VR, which is vSphere Replication. Array-based replication versus vSphere replication. VRMS and VRS, we'll talk about these components. They're the management pieces and the replication virtual appliances that go along with vSphere replication. And SVR, it's sort of an internal acronym that we use when we're talking about using vSphere replication independently of Site Recovery Manager, because we can use that as a standalone tool, as it were. Later on, I will be doing a session as well. It's a deep dive on vSphere replication, getting right down into the weeds and the guts of how the scheduler works and all the rest of those things. That is BCO4977. Feel free to attend that as well if you get the chance. So today we'll be talking about vSphere replication and Site Recovery Manager. We'll be covering sort of a recap of what they are, how they work, what they do, as well as getting some of the use cases for things like vSphere replication as a standalone tool with Site Recovery Manager and the like. We'll be talking about what's new with these tools as well, and doing sort of a frequently asked questions, some of the things that Lee and I both hear a lot of in the field from our customers and even internally from our own staff, giving you some idea of the answers that we traditionally give for those types of frequently asked questions. We will have time at the end for Q&A. By all means, we want to make sure that you're getting the value that you need out of this session, so at the end of this we should have some time left over. Let's stack up the questions and we'll just run through those when we hit the end. So, timeline of BCDR, SRM, and vSphere replication. We released Site Recovery Manager in 2008, and we'd actually won an award at VMware for the best business continuity product before there was a Site Recovery Manager, because the platform gives us these capabilities for DR, for copying them, for recovering them very easily. But in 2008, we released Site Recovery Manager. Version 1 followed very shortly thereafter by version 4. It wasn't that huge of a leap that it was worth 3 extra editions. It was just that we wanted to align it with the platform. So it used array-based replication only at that point. With version 5, we released SRM with vSphere replication. And vSphere replication was a tool that was bundled with Site Recovery Manager. It offered us a way to replicate virtual machines as well as using array-based replication. We now have the option to do this with vSphere replication. But it was part of SRM. It was bundled with Site Recovery Manager. Last year with 5.1, we basically branched them. We separated vSphere replication from Site Recovery Manager so that you could use it as a standalone tool to replicate virtual machines, copy them to another location without getting the orchestration and all of the testing and DR focus that SRM gives us. And that brings us to today with both Site Recovery Manager 5.5 and vSphere Replication 5.5 standalone or for use with SRM that we'll be talking about today. And that's probably my first Canadianism. We're talking about that today. So, we're going to talk about VR. As a standalone tool, it was included with vSphere Replication. It's a product that you can use. It comes with the platform. It exists at the hypervisor level, and you can right-click on virtual machines and replicate them to another location. It gives us the ability to do asynchronous replication of VMs, where we can basically choose a recovery point objective between 15 minutes and 24 hours for any individual VM decay. So we can copy them from one location to another. Now traditionally this has been from one vCenter instance to another vCenter instance, where we've got 2 separate clusters and 2 separate data centers, and we can replicate between the 2 of them. The replication is per VM and technically actually per VM decay. We can choose each individual disk within a virtual machine to replicate or exclude from the replication policy that we're choosing for that VM. It's integrated with vCenter and with the platform itself. As I mentioned, it's a hypervisor agent that sits within the kernel itself and does the replication at that level, and it's controlled through the web client. We can, as a standalone tool, utilize this by right-clicking on an object within the web client within any virtual machine and select the recovery options that we want, the replication options, and so forth. And as I've mentioned, we can use it with Site Recovery Manager or without, and I think Lee is going to talk in a lot more detail about some of those components and how they all fit together.
So a quick question on that slide. How many people in the room are using vSphere Essentials Plus or higher? Okay, so everybody that put their hand up, and you know, I asked this at a lot of the V forums this year, there's a lot of people out there that don't realize that you can go back and download this appliance. It's included with your platform license. So that same part of our download page on my VMware or wherever it is on the website you go for all the downloads these days, you can go back to the same location where you downloaded the ESXi image, and on that same part of that page there'll be a set of extra links for other things that are included with your license, like VDP, like vSphere Replication. So if you're one of the people that put your hands up and you're looking for a replication tool, then there is one already included with your vSphere license that you've already purchased if you're on Essentials Plus or higher. So I just wanted to make sure that everybody understood what we mean by included with vSphere Essentials Plus or higher, because it's amazing how many people you go around and they say, well, I thought I had to buy that, I saw it on the website, I didn't know where it was. So if you put your hand up, you can go back there and you can use this.
So how do we install and configure vSphere Replication? As I mentioned, it's part of the hypervisor. It's a platform component. But we do have virtual appliances that we deploy, both at the protected site and at the recovery location. What these appliances do is manage the interface for vSphere Replication, registers it as a service with vCenter, and does a couple of other components. It's the same appliance, whether we're using SRM or whether we're using it standalone. We've just got one OVF that you right-click, deploy OVF, and it basically handles the rest after you give it admin credentials and networking information and all those things. Now that initial instance, when we deploy that first virtual appliance, does 2 different things. One, it acts as that management server, the interface to vCenter, as the area when we right-click on a VM and say, I want to configure this for a 1-hour RPO. This is the function of the VRMS, that management interface type of aspect. Now, there's only one of these per site. The very first appliance that you deploy and register with a vCenter server will function in that fashion. If we try to deploy more than one, we might run into problems because that's what's registering as a service with vCenter and various other components. So it will actually error out and tell you that you've already got one registered, we can't do it again. But it also serves a secondary function, which is the vSphere Replication Server aspect, the VRS. So the VRS is what actually receives the changed blocks. When we replicate from one location to another, we're technically sending those blocks to this vSphere Replication Server function, which collates the changed blocks, aggregates them together, writes them out to disk, and does all those functions. Now, the very first initial instance serves both of those functions, but we can deploy further VRS servers to act as recipients of these changed blocks. So with Site Recovery Manager version 5 and 5.1, we could deploy up to 10 of them. And there's some changes that we'll be talking about today as well in terms of the standalone functionality for that. So we can have multiple different types of appliances to act as management or as target blocks.
And some people say, why would I want to deploy more than one? If one appliance on its own can scale up to the limits that you've published, what's the use case for going beyond one appliance? And there is a couple of other use cases we're going to look at earlier, but one of the initial examples that kind of makes sense is if you've got a multi-tenant environment where you want to allocate certain tenants' replication schedules to certain target replication appliances, then we've got customers that want to do that, so they'll deploy greater than one appliance to that site. If they're using SRM, they can do that today. And we'll talk about changes that we've made later on that make it available if you're not using SRM as well.
So it's a verily it's a straightforward installation. We deploy the appliances that we need. We pair it with its local vCenter, that's handled automatically. We can pair it with the remote vCenter, the target to which we want to replicate our virtual machines, and then we configure it. We right click on the virtual machine, we select the RPO, we select the target data store on the recovery site, and that's pretty much all there is to it. It's a very straightforward process to get the virtual machine replicating. It's all done through the web client, or you can also see some of the aspects of vSphere Replication through SRM if we're using it in that fashion. But it's really just objects in your vCenter server, you browse your inventory, you right click on the virtual machine, and you see configure replication as one of the options. We can replicate between 15 minutes and 24 hours from a recovery point perspective, recovery point objective. 15 minutes is the most aggressive that we get, and if you're looking at things like VSS quiescence for your applications and things like that, you probably don't want to be doing quiescence much more frequently than that for many of your systems, because we're taking outages every time we do it. We can select per disk a target data store, so even if a virtual machine has multiple disks associated with it, for each disk we can choose to replicate it or not replicate it, and choose different target data stores, because this operates at a level higher than the data store level. It's a kernel level agent, so we don't particularly care where the virtual machine disks reside, what type of disk they reside on, or anything along those lines. And likewise on the recovery site, it's just a matter of editing a VMX in essence to tell it where that virtual machine's disks reside on the recovery site. So we're quite flexible in terms of that disk configuration and the replication of individual virtual machines.
And I think that's just to reinforce that point. So that basically means it doesn't matter whether the source virtual machine is on local VMFS, whether it's on iSCSI, whether it's block, whether it's NFS, whether the target is local VMFS or the target is block, iSCSI, 5-channel, or file NAS. You're replicating the virtual disk. So it's from anything ESX can see to anything ESX can see as the target. So you're not bound by any other limitations in terms of your source and target data store choices.
And we can mix and match thin provisioning, thick provisioning, we don't particularly care again. Recovering in the standalone product is fairly straightforward. We right click on the replication that has taken place, like not on the virtual machine because that VM might not be existent anymore. We right click on the replication within the VR component of vCenter. We choose to recover, we select a target resource pool for it, we click finish. We can choose whether we want to power it on or not power it on, but one note is that the network cards are not attached by default. That's something with the standalone product that we want people to do manually, because if there's something wrong, if we got flaky network connectivity and we bring up the same VM in 2 different locations with the same MAC addresses and things, we're going to have problems, right?
Yeah, I think while we've got that graphic on, because we don't reuse that later on when we talk about why would you use SRM if you're using vSphere Replication already. Yeah, and this is one of the things that you have to consider is, so as Ken said, the network cards, you connect them manually if you're not using Site Recovery Manager and you're just using this on its own. And also during the recovery phase, you go through this process for each virtual machine that you're going to recover. So, as you can imagine, if you want to get to a tipping point when it might become boring to right-click on 500 VMs to recover them, you're probably then in a situation where you might want to consider looking at Site Recovery Manager to orchestrate that for you. The next obvious question in your head is probably, is there an API where I can drive this through PowerShell and do something like that? Not at the moment. The API to drive this part of it on its own is private within the code. So if you want to orchestrate it, Site Recovery Manager drives the orchestration. If you're happy to right-click on the VMs to recover them, following the wizard that you see here, then you don't need to buy Site Recovery Manager. You can just click on those VMs and recover them at the target site.
My personal tipping point is about 3 VMs. That's where I get bored. So, Lee is going to talk about some of the use cases and how we manipulate our environment with vSphere Replication. Okay,
cheers, Ken. So, pass the baton over there, Olympic style. So, what are the use cases for using it on its own, and why would you want to bother? Why would you not just go and download SRM, apart from the obvious financial transaction you would have to have with us to buy SRM? What are the use cases for using it out of the box? We've already established that you can just download it if you're on Essentials Plus or higher, so what can you do with it? So first thing you can do there is something that I guess some storage vendors call CDP, Continuous Data Protection, although this is obviously asynchronous. But we call it here local site replica. So there are lots of instances and examples, specifically in remote office environments, where you want to have a replica copy of the VM, but you're not necessarily concerned about that copy leaving the site. It's simply there so that if anything goes wrong in that satellite location and you get the phone call from the team locally at that site, the first step for recovery, maybe today, is you have to restore that VM from backup somehow. You either have to get in your car and drive there, or you have to talk the guy through it on the phone. and you have to, it's potentially not a vSphere skilled person on the other end of the phone. Now we've got lots of customers that use vSphere replication on its own to simply connect in over the WAN to that client and just do an immediate restore of the virtual machine that's held locally. Because in 9 times out of 10 cases, that might get the applications up and running quicker than it would be to restore them from backup. So local site replica is a use case. And that will work with a single virtual center. Remember, you've all seen the PowerPoint slides with SRM where we show 2 sites, 2 vCenters. And there's good reasons for having 2 vCenters in SRM design. It's so that there's no single point of failure from the VMware component side. You don't need to recover the failed site components to the other side. But SRM can't work in an environment where you've only got 1 vCenter. But there's a lot of use cases with vSphere Replication on its own where to have multiple vCenters dotted around just to protect a small number of VMs would potentially be over-engineering the solution and potentially expensive. So again, it's good that it can be used on its own. Of course, it can work between sites. So if you happen to have 2 data centers that have 2 virtual centers and there's no SRM there, you can still connect vSphere replication from one site to the other site so they can be doing point-to-point replication backwards and forwards. Absolutely, that'll work. Again, that's driven through the 5.1 web client. It's not driven through the SRM interface because remember, you haven't got SRM at this point. So you just connect the 2 sites together in the web client and you can replicate between the 2. And then also the remote office, branch office use case where you might have a couple of satellite sites that you want to replicate back to a slightly larger office. Yes, you could do that with SRM. Yes, I could install SRM at those kind of little right-hand side sites there. But if they have a single tower server with ESX on and 2 VMs, that's quite an elaborate solution just to protect 2 virtual machines at those endpoints. So in that use case, why not just use vSphere Replication on its own, point it back to the main site. So how does that look? Let's have a look at a bit of detail. So here's a typical standalone, and this is, again, the term Ken used was SVR. This is what I call it when I'm talking to customers, standalone vSphere replication. So we have our vSphere Replication Appliance that we've deployed there. It's obviously registered itself with Virtual Center, and inside each of the ESX hosts, we have the relevant piece of code to do the actual replication. So ESX version 5.0 and higher has the vSphere replication code inside it by default. There's nothing else you have to install. It's not a VIB that you have to go and get from the download site and deploy to the host. It's the right splitter, if you want to call it that. The vSphere replication filter is in the storage stack for ESX5. So that's the piece that's labeled in this diagram as VRA. So we're going to do a local site replica. We're going to replicate that VMDK1 there, and we're just going to replicate it. Could even be to a folder in the same data store. I'm not saying that's the best idea in the world, but you would let you do it. If you selected a subfolder in the same data store, you could do the replica. So what would happen? Essentially, every time that we decided we need to create a delta or a snapshot, whatever you want to call it, when we're doing the replication, it would be obviously processed via the right splitter inside ESX. That particular delta would get sent via the vSphere Replication Appliance. And obviously, this is kind of local LAN traffic here because it's all in the same site. That appliance would select one of the target ESX hosts that had access to that data store, and it would use the network file copy service within ESX to copy those deltas down to the target disks in the subfolder that you'd selected. Simple as that. So it would go up to the appliance after it had been written out, and then down to the target disk. Across 2 sites. So here we've deployed, just by chance, we have 2 VR appliances deployed to 2 sites. It's not a ROBO example. So I want to copy that virtual machine, VMDK1, over to a data store at the other site. I activate replication, right-click on the VM in vCenter. Every time I generate a delta, based on whatever RPO I've selected, that will go over to the target VR appliance. Essentially in the UI, I'll select that one as the target, and then it'll allow me to select the target data store, and then again, the scheduler will choose an ESX host, and it will write those changes via those local ESX hosts down to disk using network file copy. ROBO example. This is one that's worth kind of understanding because we're going to come back to this later on to show you some of the things that we've changed in 5.5. So here we've got 2 branch offices. You call them whatever you want, satellite office, branch office. We've got single ESX host in each location and a very small number of VMs that we want to protect. So let's say in branch 1 and 2, I've got a VMDK2 there, and I want to replicate that one back into the larger branch office, store, whatever it is. So I turn on replication, and then my flow of data is essentially going to be back to the branch office, via the VR appliance, and just like the other 2 examples, down via NFC to the target disk. Notice, and I'm specifically going to spell this out, because this is a 5.1 diagram that I drew, there's only one VR appliance in this picture. In 5.1, you can only deploy one VR appliance unless you have SRM. If you have SRM, you can deploy up to 10, which is what we mentioned a second ago. You're going to see this change subtly when we get to the 5.5 diagram later on in the session. So just remember in your heads for now, if I want to replicate that VMDK from branch 1 into the main office, it goes back across the WAN down to the local disk in that site. What if I wanted to do branch 2 and I wanted to say take VMDK 3 and replicate it but keep the replica local? So I don't want the replica to leave site. This is kind of a CDP type example. I want it to stay where it is. So with 5.1, what I have to do is, even though it's staying local, the delta that gets created whenever the scheduler determines that we need to create one based on the RPO still has to go back to the main site, because that's where the appliance is. That same delta then comes back across the WAN to be written down to that local disk, literally right where it just left. Now, it doesn't take too many of you in the room to probably figure out that that's not the most optimal architecture if you want to do that. I had a customer that wanted to manage 2 data centers, one in New York and one in New Jersey, and his virtual center was in Malmo in Sweden. So you can imagine that's quite a long round trip for that delta every time it wants to just go between New York and New Jersey. So he does that today, but he's going to be smiling a little bit broader when he sees what he can do in 5.5. So we'll come back to that. But for now, just remember, if you remember anything from this slide, remember that last big loop that you have to do if you want to keep a local copy. And I'll come back to that later on. So just to kind of go back, so that's the kind of vSphere replication, where it is today, what you can do with it in terms of use cases. So we've got a couple of short slides that I want to just go through on Site Recovery Manager. Ken's already talked about the timeline and where it's come from and where it's gone to. And hopefully most of you in the room don't need to see all the usual Site Recovery Manager PowerPoints. You kind of get it. It's a fairly simple solution to describe. It's an add-on for Virtual Center and vSphere. It's basically, at its heart, a migration tool for moving virtual machines from one place to another place using cold VM mobility. That's what it does. It allows you to build recovery objects. It allows you to spin those up at a target site, whether you've got a stretch network, whether you haven't got a stretch network, using replication as the transport for doing that. So that's what Site Recovery Manager is. So hopefully most of you are kind of familiar with how you use that.
The way I usually describe it is that it's at its core an orchestration engine. It doesn't do the replication itself. It doesn't do any WAN compression or anything along these lines. What it does is orchestrate the recovery, the sequencing, and the prioritization of the recovery of the environment. That's its core strength, and that's what it does by utilizing these other components that we have available to us.
Absolutely. So the key components for SRM haven't changed. We haven't altered this. You still have to have one virtual center server per site, whether that's the Linux virtual center server appliance, whether it's the Windows appliance, doesn't matter. Either of those are supported. They always have to be the same version. So if you're using 5.1 or 5.5, as obviously we've GA'd now, then they have to be the same version at both sites. If you're using array replication, you'll see later on they don't have to be the same versions of ESX hosts, but you have to have an SRM server as well. So the two key components at either site are those two things: Virtual Center and SRM. So they have to be the same version. So if you're going to go 5.1.5.1 or 5.5.5.5, those versions almost match. The SRM server is still a Windows install for now. Obviously we're going to look to move to an appliance model in the not too distant future, but right now SRM is still Windows based. Both components have a back-end database as well. So obviously Virtual Center has a database, SRM has a small database as well. Yes, the database can be held on the same database server that's looking after vCenter. Technically speaking, you can run SRM and Virtual Center server together. Usually in production, we'll advocate keep them separate. Obviously, if you've got a Linux Virtual Center appliance, it will be separate. If you're using Windows-based vCenter, for maintenance reasons, operational process reasons, it's usually better to spin up a separate Windows VM for SRM itself, if you can. The hosts have to be the same versions, predominantly if you're going to use vSphere replication. If you're using array replication, then, technically speaking, until 4.1 goes end of life, you could use 4.1 clusters underneath, because you can manage those with version 5 management appliances like Virtual Center and SRM. Obviously, if you're using vSphere replication, all bets are off, because we didn't have vSphere replication in version 4, and we'll never ever backport it now, because obviously 4.1 is approaching end of life in the next few years, and we're not going to backport that code. So If you want to use vSphere Replication, that's a forward-looking piece of technology, so you have to move the host to version 5 for those VMs that are going to use that technology. And again, just like vSphere Replication Standalone, Essentials Plus or higher is valid with Site Recovery Manager today. Replication options, up until 5 came along, your replication options were simple, array-based replication only. There was a big matrix of vendors on our website that had adapters for SRM, and that was your only option, array-based replication solutions. 5.0, we introduced vSphere Replication for the first time, and that was, as Ken said earlier, the only way you could use vSphere Replication. We didn't allow you to use it on its own. We didn't do that until version 5.1. So now you can use both. You can use array replication and you can use vSphere Replication. Not at the same time on the same virtual machines. Hopefully that makes sense. But you can have some virtual machine workloads that are under vSphere Replication's protection. You can have some workloads that are under array-based replication protection. And you could even have other workloads that are part of vSphere Replication, but you haven't presented them into SRM. So you haven't made them part of an SRM protection group or recovery plan. Because you might deem that they don't need to be in part of any recovery plans, and they're the tier 4 workloads, or the workloads that the application owners are not paying you any money for SRM orchestration. So you can still have them being protected and replicated with vSphere Replication, just not in the SRM UI. So you can do two things there. The workflows that we support, so these are all the version 5 workflows. Should be fairly obvious. Yes, failover automation, so disaster recovery of predefined workloads. So you build your recovery plan, eliminates all the kind of need for your manual run books. You invoke the recovery plan through the SRM UI. It will recover the virtual machines in the sequence that you have in your recovery plan, and then apply any customization you've put on top of that. So whether you've enforced dependencies, whether you've got network changes in there, it will then roll those in the order that you've defined. Non-disruptive DR testing, so the ability to leverage, if it's an array-based replication platform, array snapshots. If it's vSphere Replication, we essentially use the vCenter snapshotting mechanism to attach a redo log file to the VM and spin up a copy at the target site. That allows you to test your recovery logic without interrupting replication or the production work. Yes, there are some considerations around which network objects you attach the VMs to during that test. By default, we put a fence network up and put the VMs in there. Or you can override that and attach the virtual machines to a port group of your choosing, with the obvious proviso that it doesn't route back to the other site. Because then you're not going to have a nice experience if it does, because you're going to have two instances of your applications up and running at the same time. So hopefully that's fairly obvious. Plan migration was something new in version 5. This is essentially because we found that customers were using the DR workflow to just do operational moves of virtual machines, which was great, and it was nice to see them using SRM in that way. But unfortunately, the DR workflow was built and it didn't do any cleanup. It was kind of a bit like my 3-year-old son. He kind of takes a bunch of toys and he dumps them in one place and then doesn't bother to go back and close all of the drawers that he's just opened up in his playroom. Then I have to do that. So that was a bit like a plan migration in SRM version 4, is that SRM got the VMs to where they wanted to be, but it left a big mess in the playroom behind it, and then the parent had to come along later and tidy all that up, change the storage presentation, make sure the hosts were happy that disks had disappeared, get rid of the inventory items that now no longer existed. So plan migration automates all of that. Because in a plan migration, both sites are up. And in SRM version 5, we have a new API for talking to the storage, so we can also do nice things like, after we've unmounted the VMFS volume and detached the disks, we can tell the storage array to do synchronizations as well, to make sure that if you are in a synchronous distance apart, you've got all of the latest copy of the data at the target site. So we do all of the cleanup for you with a plan migration workflow. And then the last one that was missing from SRM version 1 and 4 was obviously failback, or reprotect as we more accurately describe it. And this is the ability, after you've failed over, to reset the environment so that should you now need to move the workloads back to where they came from, everything has been done for you to make that happen. So the storage is now replicating in the opposite direction. The workflow you used to get there in the first place has been reversed, so you can reuse it. In version 1 and 4, you had to delete it and recreate it, which was cumbersome. It's all automated in version 5, 5.1 and 5.5. And that will be the same whether you're using vSphere Replication or array-based replication. So there's no kind of a hierarchy of feature there. They're both on feature parity. So they both can do failback, they both can do plan migration, they both can do test failover. Okay, so that's a quick recap of those. Now, Ken's going to start to lead us through the next bit, which is a little section before we get to the what's new on the stuff that we get asked a lot, which will hopefully be some of the things that maybe you're thinking about right now.
Right. So frequently asked questions, then what's new, and Q&A. So frequently asked questions. When would I use SRM? With or without SRM? When do I use vSphere Replication without SRM? Well, we've talked about this a little bit. Smaller environments. I mean, not everybody has the ability to spin up multiple data centers or, engage in DR partnerships with various people and things like this. So the ability to utilize this built-in replication engine to protect your environment, because if it's small enough that the recovery isn't all that onerous, like I said, for me that cutoff is 3 VMs, but if you got 10, 15, 20 virtual machines, it's not that hard to right-click on a handful of them and recover them in the sequence that you want and so forth. So DR for these smaller environments is a great use case for Site Recovery Manager. If you need individual virtual machine recovery, so if we're utilizing array-based replication, then obviously we have whole sets of VMs that are within the environment. And SRM is designed to sit on top of these things and orchestrate these large sets of VMs. If we just need to do one virtual machine, just fail over one individual system, or even locally go to a replica that we've got, you can right-click on that VM and recover it very, very easily with the standalone tool. You can do local and inter-site replications. So again, if we're just copying between 2 local data stores, or if we've got a handful of remote offices, again, with the focus on these sort of smaller environments rather than these large-scale types of things. But if we want to replicate up to 500 virtual machines manually within a data center, we can do that very easily and very simply with vSphere Replication. And also to do location migration type of things. If you don't need to have continual, ongoing disaster recovery types of things. You're moving data centers from one location to another one, and you've got 500 virtual machines. You can manually right-click on, well, you can actually mass select a whole set of virtual machines if you want to. Right-click on all of them, say replicate to this other location, and then manually migrate them. Do your data center migrations, in essence, for free with vSphere Replication.
Yeah, I mean, that last one's quite common because, there's a lot of, the customers and partners out there that do data center relocation or data center collapse projects. And if you've got a heterogeneous mix of hardware between those endpoints, then there are hardware-based solutions that work with SRM that would allow you to do that. So things like EMC recover point, you can go from, you can plug in vendor X, Y, and Z through the recover point splitter and replicate it to the target. But then you've got to configure all that, and you've got to then set it up with SRM, and then you've got to drive it through that way. If that's a one-time deal and you're just going to work on batches of VMs and you're going to process 10, 50 VMs, then move them across, then move the next ones across, vSphere Replication works straight out of the box for doing those kind of things. So it's becoming very popular for those ad hoc requirements where you're going from data center 1 to data center 2 and both data centers have got completely different equipment in, and you just need a tool that can get the data there. And even if you set the RPO to say 24 hours and you just trickle it across over a period of weeks, then you can do that. And one of the things that we don't cover in this session, but you can pre-seed the data as well, so you can take copies of those virtual disks at a point in time, ship them to the target site, which is going to be the new home for those virtual machines after you decommission the source location, and then you can go into the UI and say, I want to replicate this VM to this data store, which is in my new data center over here, and because you've got a copy of the data there initially, we will then check some of the blocks in the source and target disks. We detect that those target disks exist in the folder that you've selected, and we will then not have to copy the whole chunk of data across that what could be a brittle WAN connection or a kind of a long flat network. And we'll only copy the changes that will happen between the time you took those copies of those VMDKs to the time you configured the replication and pointed them at their new home location. So it'll transfer a much smaller subset of the data.
Lee. You're stealing my thunder for my deep dive session.
Oh, yeah. Ken covers that in a lot. You do a lot more of that in your deep dive session, Ken.
Right, so I think you're covered, right?
Okay, so what do we miss out on? So this is always an interesting question because everybody wants an API for vSphere Replication. And kind of not wanting to make light of it, everybody says, why is there no API? Why is there no PowerShell commandlet? And if I'm in the right audience, and hopefully amongst friends, I say, well, it's because we're VMware.com and we're not VMware.org. If we, We get paid, strangely enough, and so do all the engineers. So we have to sell something, otherwise we can't build you anything. If we gave you APIs for all of this stuff, you might never come to us and say, you know what, I've got 500 VMs now and I need an orchestration solution. Does that mean the day will never come when we don't release the APIs and we start giving you the ability to kind of roll your own SRM solution without SRM's UI being there? Never say never. These things will always get kind of trickled in. It's the what we call in the motoring shows called the Mercedes S-Class principle, where things get filtered down the stack. So yeah, maybe we will make APIs available, but right now there has to be a reason to want to move to SRM, and if we just let the APIs be completely open and give you a way to orchestrate yourself, then I know, and there's a lot of you smiling in the room going, yeah, I'd do that. So there has to be a reason. But there are, getting serious for a second, there are a lot more things that you obviously miss out on by SRM not being there. It's not just about automating the recovery. As I was talking in my group discussion earlier this morning, one of the things that a lot of people forget about SRM is obviously you have the workflows in here. So we have the failover migration, you have the ability to do things like IP customization in flight, so you don't need to stretch network, we can customize the IP stack, and then when you move the VMs back, we can flip the IP stack back to what it was again in flight. Or we can run scripts as part of the recovery that talk to the physical infrastructure, the virtual infrastructure. We can run scripts in the VMs through the VM Tools API. You can set dependencies between the VMs, so you can have a very precise, dependent, orchestrated recovery. So, there's a lot of things in the top two boxes that you get with SRM that you just not going to get with vSphere Replication on its own. But then you come down to the more operationally useful things like the reporting and alerting that we build in. So, it gets lost on a lot of people that if you do something that's genuinely a mistake in production, but an operator comes in, he has an existing virtual machine that's protected in SRM, and SRM's watching it and looking after it, and then he accidentally provisions VMDKs to data stores that aren't being replicated, SRM will pick that up. SRM will see that, it'll do a recompute data stores, it'll detect that it doesn't see a copy of that disk at the target, it'll immediately start generating flags and warnings to say, hey, you know what? This VM, I was happy a minute ago, you just stuck a bunch of RDMs on it and I can't see them at the other side. Or you just attached it to an NFS export and stuck a VMDK in there, I don't see that at the other side. I can no longer recover this VM for you. You don't want to find that thing out when you cut over to the other side and realize you've left all your data on local disk because the ops guy selected the wrong data store from a list of 250 data stores and he got confused. So there is a lot of operational watchdogs, if you like, that are built into SRM that are there to protect you once you've set up your recovery plans and your protection group, so that if you ever break them, by accident, hopefully, then you find that out before it's too late and you suddenly get to the other side and realize your data's disappeared. You've still got the clicker, haven't you?
Sorry?
There
yeah. One question that I get quite a bit, and I've done a couple of blog posts on this, is about bandwidth. So when we start talking about vSphere replication, quite often the first question is, that sounds fantastic. So I've got 50 VMs, how much bandwidth do I need? It's hard to say unless you actually test it for a number of different reasons. First of all, it's totally dependent on the data change rate that you've got for those virtual machines. It's completely dependent on the recovery point objective that you're setting for those virtual machines. It's completely dependent on all of these factors, including whatever network pipes you've got. I usually recommend people set it up, test it within their local environment, replicate from one location to another within intra-data center to get the idea of what type of change rate you've got and what type of bandwidth is necessary. But often people will set that up and then they run a test. They choose one virtual machine, they say, yeah, this is fairly representative. Let's replicate that with a 15-minute RPO and see how much bandwidth it's using. We've got a 10 gig pipe between the two of them, and it uses 4 megabits per second. And people say, what's going on? But that's just an arbitrary number, roughly. Anyway. Nobody Twitter that. Yeah.
4 megabits a second bandwidth limitation.
Right. So it takes less bandwidth than you're presuming. Why is it not consuming all of this bandwidth that I've got? It's not designed around individual VM replications at its maximum. It's designed around optimizing the transfers of all the virtual machines that are being replicated from every individual host. It takes a look at all of the replications that it has. The host agent takes a look at all the replications it has configured. It aggregates those change blocks at the time of writing, and it will ship them all together per VM, but as an aggregate transfer called the lightweight delta. So it's designed to scale for multiple VMs, and we have these various limits set in place that will, it loads up a certain number of buffers, in essence, for the replica. It ships those across the wire to the recovery site. At the recovery site, it receives them, it writes them out, it sends an acknowledgement back that says, yes, I've got them. Then we free up those buffers. So on an individual VM basis, we can cap those buffers and those maximum transfers very, very quickly. But that's designed to limit the situation where we might run into, let's use all available bandwidth for all available virtual machines, and all of a sudden we're bulging at the seams and unable to achieve the recovery point objective that we've got. So the question of how much bandwidth does it need is hard to answer because that's defined by your own criteria. And why is it not utilizing all of my bandwidth is by design. It can utilize all your bandwidth if you're replicating more than one virtual machine, which is presumably going to be the case for your DR planning purposes. Now, we'll talk a little bit more in a minute or two here about some other changes that we're going to see with vSphere Replication that if you really want to use all your bandwidth, it's there for you.
So one thing on this, this slide to finish, so the question would be, well, what do people do today? And one of the things that partners do today, our customers do today, is they'll pick some representative workloads, because remember this, when you turn on vSphere Replication, it's kind of non-disruptive to the virtual machine. And they'll enable replication for a random sample of VMs. And they won't declare the service is live yet, or DR is now up and running, or whatever you want to call it. But they'll just turn replication on. Because once replication's on and running, what you start seeing in vCenter, if you look at the individual virtual machines, we start generating events every time we do a delta transfer. And in those events, we log the change rate that happened for that virtual machine. So if the delta was, say, 500 meg or 450 meg, it'll have that value in bytes inside that event. So you can... and actually, I don't know if he's in the room or not, but a good friend of ours, Alan Reneuf, who does a lots of PowerShell stuff, he wrote a nice little script that he gave away on his blog that filters for all of those events and creates a nice little spreadsheet with a list of replications and the sizes of those virtual machines over a period of time. So if you know Alan's blog, I don't think we have a link for it, but is it Virtual Al?
Virtual-al.net.
Yeah, if you can't find that, drop Ken a tweet on VMKen, because it'll be easier to remember than my surname and first name together. But that script is out there, and there's also hopefully going to be some tools that we're going to make available, potentially in the not too distant future, that you can download for free as well to use to do some of this capacity planning and sizing. So workloads not suitable for vSphere Replication. Let's go through these. So some of the things are workloads that you potentially, whether you're using vSphere Replication or SRM, you wouldn't want to replicate anyway. So in an SRM environment, it might be things like AD, anything that's a data center service that you've got backup domain controllers at the target site. You've already got NCP servers down there. Whatever it is, you're not going to usually replicate those workloads. Virtual Center, yes, you could, in theory, replicate Virtual Center with vSphere Replication. Our colleague Duncan blogged that. I only said that because I saw you sat down in the front row there, Duncan. So there is a process to do it, but as Duncan rightly said on his blog, it's not technically supported, but it could be done. And we know that you like to do things that we don't support. So if you want to do it, go on to yellowbricks.com, which is Duncan's blog, and he's I don't know when that article was, a few months ago. He's got a search wizard on there. You'll be able to find that article somewhere. So yes, it could be done. The other one is potentially high churn virtual machines. So one of the kind of jump off points is when should I use array replication versus vSphere replication? Well, a simple metric is the RPO. We only support officially RPOs as aggressive as 15 minutes. Technically, could we go faster than that? Do we go faster than that internally? Yes, we do. Again, in an unsupported scenario, we can say that amongst friends, but that's not what we certify and support. So 15 minutes, and it's also, we don't let you move the slider any further to the left in the UI, so you can try for it all you like, but you will not be able to push that slider further left. So that's how we enforce that on all of you.
There are unsupported ways to do that too.
Yeah, we're not going to blog those ones, and don't go looking for them either. So yeah, if it's that kind of virtual machine, then again, remember that array replication might be the solution for you. Also your RPO you can achieve might be affected by VSS. VSS is obviously not a VMware component or framework. If you've got a particularly aggressive virtual machine in terms of write changes, then those of you that are familiar with VSS or use it, there's no guarantee that VSS will quiesce the VM within 15 minutes anyway. We've seen lots of examples in the field of VSS takes on some VMs an hour to get to a point where it's happy, 45 minutes, 30 minutes. So you might see examples where people say, I couldn't use vSphere Replication because it couldn't hit a 15-minute RPO. That's usually because they also had the tick box enabled for VSS, and VSS wasn't actually able to quiesce the VM within a 15-minute window to satisfy the RPO, so you either have to just accept that, or you have to reset your own expectations in terms of what RPO you can achieve.
If you really want, we can replicate a completely quiescent virtual machine for you that never actually processes anything, but that's not a very functional SQL server. Sorry.
And then into VM write ordered fidelity. So our SCSI filter and the way we obviously ensure write order consistency is within the virtual machine itself. It's not across multiple virtual machines across hosts. So if your virtual machine can see 60 VMDKs, because each of those VMDKs has its own SCSI stack and we've got a filter attached to each of them, then we can maintain write order consistency across all 60 VMDKs for that virtual machine. If you've got another virtual machine that's 15 hosts away or 15 racks away in a different chassis with its own VMDKs, there's no coordination between those two virtual machines. They're each writing to their own disks. So write order consistency is within the context of the virtual machine and the virtual disk that it can see. So if you want to be able to group lots of workloads together and use something like SRM, then if that's a dependency you have, then you might be using array replication with consistency groups, device groups on a storage array to do that, if you want to fit into that particular use case. Zero RPO, so again, if you need zero RPO, then you're presumably inside a synchronous distance between your two sites, which means you can use synchronous replication, which means that you would use that to protect those workloads. And then there are some unsupported ones. This is not a definitive list. These are just the ones that Ken and I put down. So physical RDMs we can't handle for the simple reason that if you have a physical RDM, the data path is different. It doesn't go through the virtual SCSI driver that the VMDK uses. It bypasses it. Therefore, the filter wouldn't see the I/O. So pretty easy, right? The I/O goes that way, the filter's this way, wouldn't see anything. So we can't do physical RDM. Virtual RDMs, fine, because that goes through the SCSI path. Multi-writer VMDKs, we don't support those. And there are a couple of other things, and they're detailed in the release notes.
ISOs and templates and things along those lines.
Yeah. And you do this one.
Right. So using them together, yes, absolutely. We can replicate the same virtual machine with vSphere Replication and array-based replication, but that would be a terrible idea. From an SRM perspective, we can utilize and interoperate between both of them. So you have some virtual machines protected by array-based replication, some protected by vSphere Replication. That's utterly fine. You can even mix them into the same protection group, the same recovery plan. It's completely fungible from our perspective. Now, as we mentioned, you don't really want to replicate the same virtual machine twice for a number of different reasons. First of all, well, we don't want it to have to belong to multiple protection groups. It can't belong to multiple protection groups if, the way we protect that virtual machine. But if we fail over a virtual machine that's protected by vSphere Replication, then all of a sudden that breaks our array-based replication. And likewise, if we fail over the array-based replication, then our VR state gets very confused. So you can mix and match them, but not for the same virtual machine. So, what's new? We got 12 minutes left. I'll throw the baton again and let you.
So the first thing that we've changed in 5.5 is that we now support storage vMotion, storage DRS, if you've got virtual machines protected with SRM. And the big change here is that essentially in version 5.1 or 5.0, if you move the virtual machines around, then obviously SRM wouldn't like that. SRM is watching what you're doing with the disk files. If the disk files go from LUN 1 to LUN 2, you're going to get a state change inside Site Recovery Manager because it's going to flag those alarms and alerts to say, where's that VM gone? It was there, now it's here. So SRM would be tracking that virtual machine to say, you know what, you need to tell me that I can reconfigure this virtual machine for replication, which means I can update the SRM database to tell it on both sides where those disk files are. So now if you're using storage DRS or storage vMotion, then if you do move the protected site VMDKs, then we will update the SRM environment for you so that that is tracked. So you can do that. I mean, you could do it before, but you just have to remember to go back into the UI and configure it yourself by clicking on the little button to say, yeah, reconfigure the database, which essentially meant just update it. Array-based replication. So if you're going to storage vMotion or you want to storage vMotion virtual machines around that are using array replication, you must do it within an array consistency group for this to work. So if you've got LUNs 1, 2, 3, 4, and 5, and they're not in a consistency group, this won't work. The way that it works is if you want to be able to move virtual machines around within that SDRS cluster, then those 5 LUNs are in the same data store cluster, and on the back-end array, they are in the same array device group. So you wrap a little bubble around them, and then if you want to move the virtual machine disk files around, inside that little container of 5 LUNs, SRM 5.5 will be happy. And you won't get lots of alarms and alerts generated. So Key point there, make sure you're using consistency groups on the array, device groups, journal groups, whatever your particular vendor calls them. For vSphere replication, not the same limitations because we're not talking about LUNs and devices here because we're replicating the VMDKs. The main thing here is if you move the virtual machine disks around with vSphere replication. vSphere replication's always kind of been okay with this because it's, again, not dependent on array backend moves. But yeah, there were some things that would kind of freak people out, like if there was a full synchronization task in progress and somebody else in the other team decided to move the VM from LUN 1 to LUN 2. There was the concept that maybe that full sync would restart from the beginning, which was a bit of a pain if you got 98% of the way through. So we don't do that anymore. We'll just continue from where it left off. So there's some nice little things that we've changed in there to make this more operationally friendly. And vSAN and vSphere replication. So some people say, what can we do for replication with vSAN? Obviously, we announced this morning vSAN is going to be in public beta, so you can all start and kick the tires on it. If you want to do replication from one vSAN data store to another vSAN data store, can you use vSphere replication to do that? Yes. So we support that from 5.5. We've been testing this throughout the beta, so we'll support that once vSAN goes GA. But if you're doing it through the beta, you can play with it yourself.
And again, it's support not just vSAN to vSAN, it's anything to anything, right? So vSAN to USB thumb drive, sure, go for it. That's, again, probably unsupported. I don't think you'll see that on the HCL.
You probably shouldn't have said that.
Yeah. Here goes another tweet. Damn it.
So vSphere replication appliances, and this comes back to something I said earlier about the number of appliances you can deploy. Remember, in 5.1, if you're using vSphere replication on its own, it's one appliance for the virtual center. If you wanted to deploy more than one appliance, you had to be using SRM. In 5.5, we will now let you deploy up to 10 vSphere replication appliances per virtual center, whether you're using SRM or not. So even if you're just using vSphere replication in what we've been calling standalone today, you can do that. Why would you want to? So remember this example I showed you earlier with branch 1 and 2, where we had the horrible scenario where we wanted to replicate the virtual machine disk files, but we potentially want to keep them local. We don't want them to leave site. And remember we had that big loop where they had to go from, the virtual center was in Malmo and I wanted to go from New York to New Jersey, but then I had to send the Delta via Malmo every time, and that's probably not the best thing in the world. So in 5.5, if you do want to do that, what you can do is you can deploy an additional pair of VR appliances at those two endpoints. So I could deploy one in New York and one in New Jersey, and then when I configure replication, and I want it to stay in those two endpoints, now all of the traffic will stay local to those sites. But they'll be managed from that virtual center server in Malmo. No longer do I have to hop across the Atlantic every time I want to shift 500 mega data. So for customers that are doing this, and a lot of people doing this, this gives them a lot of extra benefits and flexibility in how this solution now works. So up to 10 vSphere replication appliances can be deployed across multiple endpoint sites. So Ken's going to talk a little bit about multi-point in time recovery, which is something, again, new in 5.5.
This is a very exciting thing for me personally. Multiple point in time is something that we've been asked for quite a bit over the last couple of years with vSphere replication. The way it currently works with 5.1 is that we retain and we replicate to the most current copy of our virtual machine. The way that works, basically, we fill a redo log, turn that into a snapshot, commit the snapshot. For multiple point in time, what we're doing is allowing you to configure by policy a number of historical snapshots that you want to retain. So rather than just collapsing the snapshot every time we do a write, we stack up the snapshots in accordance with the policy that you've dictated for every individual VMDK. So we support up to 24 points in time because they're represented as snapshots and we don't want to exceed the snapshot tree length. So when we configure, it's just yet another option that we see within the interface when we right-click on a virtual machine and we're selecting our policies for configuration, recovery point, target, and our number of point-in-time instances. It's up to 24, but you can carve that up however you want. 1 per day for 24 days, 24 for 1 day, and vSphere replication then just retains those snapshots on an ongoing basis in accordance with that policy. We will always fail over to the most recent point in time, and this is supported with the standalone or with Site Recovery Manager. So we fail over to the most current point in time, the most recent replica, and if we're using SRM, that will have all of the customization and things like that applied to it. And then we present them just as standard snapshots through a snapshot manager. The idea is that it might not be a specialized BCDR person who is then taking a look at the historical points in time. An application owner might look at it and say, this is wrong, something went wrong, yesterday, I need to go back to last Tuesday or whatever it happens to be. And they can do it in a very easy fashion that people have been used to for many, many years now. So we fail over to the most recent point in time, up to 24 of them, manually revert if we've decided that the point in time that we've chosen isn't the right one. How does it work? Well, we have an RPO and we have a retention policy. And there's an interplay between the two of them. So for example, if we have an RPO dictated of 4 hours, that means that we're creating replicas on an ongoing basis of about every 4 hours. But if our retention policy differs from our RPO, then we need to expire some of these historical replicas as we go. So as we start accruing new points in time, we expire and retire the old ones, and they get cleaned up at every time of replication. So in essence, we always keep the most recent one and the historical ones until we've hit that maximum that has been configured, and delete the old one. But we also might end up with multiple recovery points that have been created within a window, within a slot for our retention. So we always keep the most recent one, but if we have multiple other points in time within our retention slot, then we can obviously expire some of them as they're not necessary within our policy. So again, we're cleaning up the ongoing retention of current points in time, and we're expiring the old points in time, irrespective of the recovery point objective that has been defined for those virtual machines. So we can have very aggressive 15-minute recovery point objectives, creating lots and lots and lots of these points in time, but the retention policy will dictate how they get cleaned up on the back end to be in compliance with the policy that you've crafted for them.
I mean, just one thing to say on that last slide. So the other thing to think about for MPIT is that, and you should also get a warning in the UI, I think, for this guy, is it's possible, depending on your RPO, that you might not satisfy the requirements that you've configured. You know, if you said, as in this example here, we've got a retention of 3 instances or whatever it is, if you set an RPO of 24 hours, and you said you wanted to keep 24 instances per day, you're probably not going to create 24 instances per day if you've set the RPO to 24 hours, because you might only create 3 or 4 during that day. So, if you ever see warnings to say you're not replicating the VM frequently enough to actually satisfy how many you want to keep over that period of time, it's because the RPO is too lax. You've actually set the RPO way out there, and you said, I want to try and keep multiple copies. So you might get a warning to say that if you've set a relaxed RPO, for example.
So we've got a few minutes for questions. Does anyone have any questions about what we've been talking about? You're going to have to yell them out, because my mom told me I'd never amount to anything. I said, no, I will present to 1,000 people at VMworld. And here I am a week later. Yes? The maximum retention policy is 24. Whether it's in 1 day or across 24 days, we don't care how that gets sliced and diced. Yeah. Sorry, another one. The question is, can you replicate to more than one location? No. We can replicate from many different locations to one location if we want to, but we can't split a write, in essence, to replicate to multiple environments. Yes?
In the chart you had data center A and B, the remote ones, can I go from B to A instead of back to the main?
Yes, you can. So yeah, we could. So if you can go in any direction that you want between those two links. So we should probably, if anybody else has a question, if you want to come down the front, we should probably wrap it up there and let everybody else go to the next session.
And we'll probably can take a Halley's Comet trail of people behind us out into the hallway as well. But
so
I want to make sure that
thanks for your time. I think we're just bang on time.
Thank you, everyone. Thank you.